Mechanical engineering is one of the most flexible engineering degrees that you can do in university. Any sector, any industry, any job type is at your disposal once you graduate. But it's important to be thinking about what type of direction you want to go as you exit university. Most engineering curriculums start out the same. You have your core math classes and physics classes and engineering fundamental courses, but somewhere around year 2 and certainly halfway through the curriculum, you should have an understanding of what direction you want to head after you complete your degree. This way, you're very intentional about the tech electives that you choose, the internships that you commit to, the professors that you invest in, the engineering societies and organizations and clubs that you participate in, if you're going to conduct research, if you're going to be a grader for a course, and all the things that you spend your time doing during university so that you have an advantage in getting your dream job as you graduate. There's several factors to consider when choosing the best type of mechanical engineering job for you, which is how interesting that sector is to you, how good the salary is, the amount of jobs available, how innovative or creative you can be in that role, and of course, what the forecasts are for that role in the future. So in this video, we're going to tier the top 10 mechanical engineering jobs that you can do after university, and we're starting right now. Hey 1% Nation, I'm Jake Voorhees and welcome back to the 1% Engineer Show, where we empower young engineers to rise to the top 1% of their career. So if this is you, make sure you hit the notification bell and subscribe. This is episode 138 of the show, so if you're new here, make sure you check out our other videos. See the description below for links to the 1% Engineer Kit, access to our Discord server with 1,400 engineers, our IG page, and more. This video is paired with my reaction to Shane Hummus's engineering degree tier list, along with my own video that ranks the best engineering majors, and now we're taking a look at the best types of jobs that mechanical engineers can get after university. Make sure you comment below with any question that you have in engineering. I'm responding to every single comment on the channel nowadays. So with that being said, guys, let's jump right into this video. With job type number 1, something that was left out of the best majors video, and I've gotten so many questions for this, and it is mechatronics engineering. The reason why it was left out of the degree tier list is because there's only 3 ABET accredited mechanical engineering bachelor's programs in the country. That's right, it's still so new that they have not added it to too many universities, so you have to major in either electrical engineering or mechanical engineering in order to become a mechatronics engineer. Mechatronics is a multidisciplinary field that combines several types of engineering, electrical, computer, and of course mechanical, and refers to the skill sets needed in the contemporary advanced automated manufacturing industry. At the intersection of mechanics, electronics, and computing, mechatronics specialists create simpler, smarter systems. Mechatronics is an essential foundation for the expected growth in automation and manufacturing. Mechatronics engineers work in all aspects of the development of products, from design and testing right through to manufacturing. There is almost no product in the world that is solely electronic or solely mechanical in nature. With the growing capabilities of electronics, modern mechanical systems are embedded with electronics and controls. This means that the lines between each discipline are becoming increasingly blurred, and there is a growing demand for mechatronics engineers whose knowledge is strong across all of these areas. Mechatronics engineers have distinct personalities. They tend to be investigative individuals, which means they're intellectual, introspective, and inquisitive. They are curious, methodical, rational, analytical, and logical. Some of them are also realistic, meaning they're independent, stable, persistent, genuine, practical, and thrifty. The Bureau of Labor Statistics unfortunately does not report specifically on mechatronics engineers, but there's data to suggest that mechatronics engineers make somewhere between mechanical and electrical engineering salaries in the $90,000 range. Mechatronics is the future. If you want to work with robotics, this is a subset of mechatronics. I get so many questions about that. And I think a mechanical engineer who actually is a sophisticated coder has a huge advantage when walking into the mechatronics industry. Of course, you can get your master's degree in mechatronics or computer science and truly have a great career in front of you. But regardless, guys, I think mechatronics is one of the best career avenues for mechanical engineers, which is why we're putting it at number 1, and it is certainly S tier. Next up, we have manufacturing engineering. Manufacturing engineers focus on the design and operation of integrated systems for the production of high-quality, economically competitive products. These systems may include computer networks, robotics, machine tools, and materials handling equipment. Manufacturing engineers develop and create physical artifacts, production processes, and technology. technology. It is a very broad area which includes the design and development of products. Manufacturing engineering is a part of industrial and systems engineering and has strong overlaps with mechanical engineering. There are very few industrial engineers who graduate with that degree each year, and there's almost 300,000 working industrial engineers in the United States, and a lot of mechanical engineers go into manufacturing engineering roles. Manufacturing engineers' success or failure directly impacts the advancement of technology and the spread of innovation. This field of manufacturing engineering emerged from tool and die disciplines in the early 20th century, and it greatly expanded when countries introduced these three variables: numerical control machine tools and automated systems of production, advanced statistical methods of quality control, and industrial robots on the factory floor. Some responsibilities of manufacturing engineers are developing processes by analyzing product requirements, researching, testing, implementing, and improving manufacturing methods. They may provide engineering support to manufacturing, including day-to-day problem solving of process deficiencies and product defects, as well as updating process documentation. These engineers may evaluate and improve manufacturing methods, utilize knowledge of product requirements, material types, part features, machining processes, etc. And they may assure product and process quality by design inspection methods, testing process capabilities, establishing standards, and confirming manufacturing processes. Manufacturing engineering is not the highest salary, but there are so many roles out there in manufacturing engineering. They don't actually always require an engineering degree. That's why ZipRecruiter has almost 250,000 roles out there. And because of these reasons, I'm putting this as a B tier job option. Next up, the third job option is automation engineering. Automation engineers are experts who have the knowledge and ability to design, create, develop, and manage machines and systems. For example, factory automation, process automation, and warehouse automation. Automation engineers can design, program, simulate, and test automated machinery and processes, and usually are employed in industries such as the energy sector in plants, car manufacturing facilities, or food processing plants and robots. Automation engineers are responsible for creating detailed design specifications and other documents, develop automation software based on specific requirements for the process involved, and conform to international or local standards. There's 150,000 jobs out there for automation engineering. The salary is okay, just around average mechanical engineering salary, a little bit below 90,000. I think it's a great industry. It's pretty flexible. You can work in a lot of different sectors, and for these reasons, automation engineering for a mechanical engineer is an A tier option. All right, option number 4 is process engineering. Process engineers provide the chemical or biochemical processes and equipment that are used to turn raw materials into an end product and is an essential part of the manufacturing industry. Process engineers create, set specifications, develop, implement, and monitor this equipment or these processes as part of the manufacturing system. Within pharmaceutical and medical device manufacturing, the processes involved can be chemical or biochemical. Process engineering is at work during all stages of a continuous manufacturing process. These engineers can be designing innovative processes and equipment for a new facility, or they can be involved in the modification and optimization of equipment and processes that are already in place. As a result, process engineers work with people all across the manufacturing system, including R&D, production staff, management, and even customers. What's the difference between process engineering and manufacturing engineering? Good question. Process engineers work in process or continuous manufacturing. This takes formulation or recipe of ingredients and blends them together using a chemical reaction, heat, cold, fermentation, etc., continuous or in a batch until a final product is usually a liquid, powder, gas, or solid. Mechanical engineers can work in gas and oil, chemical engineering, metallurgical engineering, and all types of places where you can have a process engineering or a continuous manufacturing application. In a process manufacturing factory, you typically find piping, plumbing, tanks, flow valves, steam valves, temperature gauges, boilers, vessels, reactor vessels, crankers, distillation columns, heat exchangers, boilers, steam pipes. You get the idea, and this is why mechanical engineers have to take fluid mechanics and thermodynamics, because you can be a process engineer. The salary on certain websites is a little bit lower, but there are so many jobs available, and if you get into the chemical sector or the gas and oil sector, you can make over 6 figures easily, and that's why we're labeling process engineering as an A tier job option for mechanical engineers. All right, the next job option is heating, ventilation, and air conditioning engineering, also known as HVAC systems. HVAC systems are an integral part of most contemporary buildings. The professionals who design the systems that control air quality and temperature are known as HVAC engineers. HVAC engineers are a category of mechanical engineers, and their work is coordinated with other construction specialists. These engineers often have have expertise in trades such as electrical or plumbing that are part of the climate control systems. They must be familiar with federal and local standards, for example, air quality regulations. Engineering an effective HVAC system requires the ability to perform heat load and loss calculations and an understanding of how air flows through various types of structures. There are endless considerations when designing systems to fit the special needs of hospitals, restaurants, schools, and areas such as computer rooms. Think about what just happened during COVID-19. All of the hospitals have what they call a negative pressure environment so that there is no airflow that exits the hospital, it all stays within. It is mechanical engineers who work with these types of systems. HVAC engineers assess the needs of building occupants and the purpose of a structure in order to design an optimal climate control system. The design encompasses the layout of all system components and usually includes schematics or other drawings. HVAC engineers plan and coordinate every aspect of a system installation. They ensure that all safety procedures are followed and that the work is completed according to code. HVAC engineers make a little bit below average on the mechanical engineering salary spectrum, and it's not that exciting of an industry. I've heard mechanical engineers talk about it as the HVAC trap. It can be tedious and redundant doing the same thing over and over again, but there are a lot of job opportunities out there. It is one of the 3 options for the PE as a mechanical engineer, but it's not good enough to make it above B tier, so that's what it scored for this video. All right, halfway through and into one of my favorite types of engineering, aerospace engineering. I get a lot of questions from engineers like, can a mechanical engineer work as an aerospace engineer? And the answer is absolutely right. In fact, it is far more popular of an option, and also I personally advise that you study mechanical engineering instead of aerospace engineering if that's what you want to do for your career. What if you decide halfway through university that you don't like aerospace engineering, or even worse, you get an AE degree, you get out into the workforce and you don't like it and you wish you had ME so that you could have more options and more potential? Then you're in a bad spot. You can always get a job in aerospace engineering with an ME degree and then go on and get your master's either funded by your employer, or you can get a research assistantship like I did and not have to pay for it at all. But I think it's much better to do mechanical engineering and then pursue aerospace engineering if that's what you want to do, which is why it's on this list. Aerospace engineers develop leading edge technologies and integrate them into aerospace vehicle systems used for transportation, communications, explorations, and defense applications. This involves the design and manufacturing of aircraft, spacecraft, propulsion systems, satellites, and missiles, as well as the design and testing of aircraft and aerospace products, components, and subassemblies. Successful aerospace engineers possess in-depth skills in and the understanding of aerodynamics, materials and structures, propulsion, vehicle dynamics and control, and software. I get a lot of questions about astronautical engineering, which is aerospace engineering outside of the atmosphere, out into outer space. And for example, Purdue, a great astronautical program, talks about these applications for an astronautical engineer, which is designing and testing rocket engines, analyzing and optimizing orbital trajectories for spacecraft, and developing control systems for rockets and spacecraft. Here's a list of companies you could work for in this avenue: ATA Engineering, Ball Aerospace, Belcan, Blue Origin, Boeing, Butler America, Dassault Falcon Jet, General Electric, Gulfstream, Lockheed Martin, Military Services, NASA, NAS, NASIC, NAVAIR, Northrop Grumman, Orbital ATK, Rolls-Royce, SpaceX, and Xcore Aerospace. I think astronautical engineering is the future. I cannot wait to see what we do with moon colonies and Mars colonies and becoming an interplanetary species in our lifetime. Yes, it's happening, guys. And that's why aerospace engineering is our next S-tier job option for mechanical engineers. All right, next up is biomedical engineering. I was a little hard on biomedical engineering in my best engineering majors list by putting it last at number 11th, and that's mostly because there are so few jobs in biomedical engineering. I dug in and did more research, and I see that about 1/3 of BME majors actually go on to med school to try and be some sort of doctor or healthcare professional, but some of them actually do become biomedical engineers. What's a good avenue to get into that? It's not to study biomedical engineering, and it's to do exactly this: study mechanical engineering and then pursue biomedical engineering as a career afterwards. Again, just like aerospace, process engineering, or any type of engineering on this list, you can go to grad school either funded by your employer or go take a research assistantship assignment, and so that you get it fully funded and paid for, and do that after university, after you know you like it with your internships, after you've actually gotten a job in this sector and are confident that you want to do this for your career, and then you can either stay in that sector or go get a grad degree. Biomedical engineering is the application of the principles and problem-solving techniques of engineering to biology and medicine. This is evident throughout healthcare, from diagnosis and analysis to treatment and recovery, and has entered the public conscious through the proliferation of implantable medical devices such as pacemakers and artificial hips, to more futuristic technologies such as stem cell engineering and 3D printing of organs and body parts. Biomedical engineers work in a wide variety of settings and disciplines. There are opportunities in industry for innovating, designing, and developing new technologies, in academia furthering research and pushing the frontiers of what is medically possible, as well as testing, implanting, and developing new diagnostic tools and medical equipment, and in government for establishing safety standards for medical devices. Many biomedical engineers find employment in cutting-edge startup companies or as entrepreneurs themselves. Because you have to go on and get a graduate degree most of the time, and there's so few jobs as a biomedical engineer if you want to just choose that, I still have to be a little hard on biomedical engineering and put it in B tier. It's not a bad career if you absolutely love it and want it, and you're certain that this is what you want for the rest of your future, but I just can't put biomedical in A tier, even though the salary is decent, around $90,000 average, and even though the Bureau of Labor Statistics reports only 21,000 working employed biomedical engineers, there are over 100,000 jobs listed on ZipRecruiter, but B tier it is. Next up, we have automotive engineering. Automotive engineering is a branch of vehicle engineering that focuses on the application, design, and manufacturing of various types of automobiles. This field of engineering involves the direct application of mathematics in the design and production of vehicles. Engineering disciplines that may be practiced in this field include safety engineering, vehicle electronics, quality management, and fuel economy and emissions. Automotive engineering may also be referred to as automobile engineering. Automotive engineers work with other engineers to enhance the technical performance, aesthetics, and software of vehicles. Common responsibilities of an automotive engineer include designing and testing various components of vehicles, including fuel technologies and safety systems. They may also come up with and design new vehicle models or vehicle systems using engineer design software. I've talked about automotive engineering in other videos, but let's take a look at this powertrain controls engineer role. The duties include planning and conducting tests to support calibration of powertrains in the area of combustion, emissions, and control, fuel economy, drivability, and electrification. They may also perform root cause analysis of issues, develop and confirm countermeasures, support emissions testings, and resolution of powertrain challenges. They may investigate powertrain field issues and author technical reports for a wide global audience. I get a lot of questions about automotive engineering. A lot of people actually work in this sector without an engineering degree, so if you look up the salary, it's a little bit on the low end. But either way, I put this job option as A tier for mechanical engineering. Okay, number 9 as a job option for MEs is research and development engineering. Research and development engineers generally execute research and tests on product ideas, develop new products, and perform redesigns. They are employed in many industries, including manufacturing, electrical, and science-based companies. Their duties may vary and depend on the industries they work in. Responsibilities of these engineers include developing new technologies, designing products, and managing the projects until they are completed. Additionally, they lead the project team members to manage their schedules, design the project plans, and collaborate with key departments in developing new products. Some of the duties may include leading a team of software quality assurance test engineers in the prioritization of assessment of tasks and the solving of technical problems, manage PC-based development of network control software, manage quality issues during development and production, and manage and maintain production equipment, including conformance to ISO calibration requirements. It's very common for research and development engineers to have an advanced degree and work in academia because that's where most of the papers and most of the research funding lies. As to work at a university as a full-time researcher, or you can get your PhD and become a professor if you choose. The salary is pretty good in research and development, and there are hundreds of thousands of job opportunities in this avenue, and for that reason we're ranking it as an A tier option. Last but not least, for job options for mechanical engineers is instrumentation engineering. Instrumentation engineering is the engineering specialization focused on the principle and operation of measuring instruments that are used in design and configuration of automated systems. These areas include electrical and pneumatic domains and the control of quantities that are being measured. These engineers typically work for industries with automated processes such as chemical or manufacturing plants, with the goal of improving system productivity, reliability, safety, or optimization and stability. To control the parameters in a process or in a particular system, devices such as microprocessors, microcontrollers, or PLCs are used, but their ultimate aim is to control the the parameters of a system. Electrical engineers can also be instrumentation engineers, but mechanical engineers will work on the design of the physical components of these instrumentation practices. Instrumentation engineering is loosely defined because the required tasks are very domain dependent. An expert in biomedical instrumentation of laboratory rats has very different concerns than an expert in rocket instrumentation. Common concerns of both are the selection of appropriate sensors based on size, weight, cost, reliability, accuracy, longevity, environmental robustness, and frequency response. Some sensors are literally fired in artillery shells. Others sense thermonuclear explosions until they are destroyed. And variable sensor data must be recorded, transmitted, or displayed. Recording rates and capacities vary enormously. As you can see, engineers can work in most likely any industry because so many sectors need some level of instrumentation to record data, make changes, make redesigns, and improve systems. Instrumentation engineering salary is pretty good, about average, just around $90,000 a year, with a lot of job opportunities, not as many as research and development, automation, process, or manufacturing, but tens of thousands of jobs in the workforce. So that's why instrumentation engineering gets an A tier rating by me. Okay, there you have it, guys. 10 tiers of mechanical engineering job options. Which one do you guys like? Which type of mechanical engineering job do you want to pursue after graduation? Comment below. What do you think of this video? Let me know what I missed. Should one of these sectors been listed as S tier if it was A, or A tier if it was B tier? Let me know in the comments. What is your dream job for mechanical engineering? Make sure you comment down below and maybe we can make a video just for that. I had a lot of fun making this video, guys. I get a lot of hits on the mechanical engineering videos, even though there's more electrical and civil engineering job opportunities out there in the world. There's something about mechanical engineering that gets researched a lot. So I'm going to keep making videos just for you guys. Thanks again for watching the 1% Engineer Show, guys, where we empower young engineers to rise to the top 1% of their career. So if this is you, make sure you hit the notification bell and subscribe. Check the links below, join our Discord server, follow us on Instagram. Thanks for watching, guys, and we'll see you again in another video. Bye-bye.